right, welcome to the stage, Rick Franzosa, the moderator for this session.
Well, welcome everyone, and thanks for joining today. Let's start with familiarizing ourselves with the event tool. If you have not been to one of these sessions before, we have a chat. You can look around and find the chat in the tabs across the top, and leave a message where you're located and that sort of thing. But please post all your questions in the Q&A tab, not the chat tab. We'll be taking the questions at the conclusion, so please post them in the Q&A tab at any point during the session. But figure we'll be probably 45-50 minutes into the session before we actually get to answering the questions. And if those questions are not answered live, we will certainly, the IoT World staff will certainly have them answered via email response or in some other way after the session. So the track will run 59 minutes, and we'll have you out of here on time. Fun fact, it actually ends at 59 minutes, even if we're still talking. It would be impossible to run a virtual session like this without our sponsors. So we want to thank our sponsor for this session, Influx Data. All right, with the housekeeping out of the way, I'd like to introduce our topic and speakers. Topic today is building data infrastructure for predictive operations. I'm Rick Franzosa, the moderator I'm the VP of Research for Manufacturing from TechClarity. And I'll have the others introduce themselves. We have three incredible speakers today. First, Benjamin Corbett, Solutions Engineer from Influx Data. Ben, please introduce yourself to the audience.
Thank you very much, Rick. So yeah, very happy to be here. My name is Benjamin Corbett. I work for Influx Data. I'm part of the kind of customer-facing solutions engineering team. So my whole existence is to work with customers and prospects to understand if InfluxDB is going to be a good fit for their use case. So lots of conversations with customers who are kind of new to the time series world, new to kind of industrial data ops. And if it looks like it is a good fit, supporting things like evaluations and just helping for them to be successful. Used to work in professional services, building IoT platforms, and before that was a mechanical engineer in the pharmaceutical sector. So I'm very much at home in kind of the industrial IoT space. Thanks, Rick.
Great, thanks, Ben. Next, Sam Elsner, VP of Product Experience from Litmus. Sam, you want to?
Sure. Thanks, Rick. Thanks, everybody. Pleasure to be here today. Thank you again to the IoT World Group for the invitation. It's a real honor. I am Sam Elsner. I've worked in the industrial automation space for about 15 years. I started with Kepware back in 2010, 2011. I built out the sales engineering team and the solutions consulting team there. We did a lot of pre and post sales work, a lot of internal product strategy, product marketing. And now I've moved over to Litmus to help grow and scale that business and am focused on internal folks and external folks as they engage the product in every aspect of it, technical, business-wise, roadmaps. So a lot of market analysis, a lot of customer engagement, a lot of building systems and seeing what works and what doesn't work. So I'm also at home in this new role as much as the old role was a bit more hands-on. Thanks.
Great. And finally, Calvin Hamas, digital manufacturing leader from Sky.io.
Awesome. Thanks, Rick, and thanks IoT World for inviting me to this. I'm a software guy by trade, and I just kind of fell into this OT space. So a lot of my job is helping bridge the two worlds together, because a lot of times they don't speak the same languages, and just getting them on the same page is usually the hardest piece of any type of these types of projects.
Excellent. All right. So we've broken the session into three different topics. The first topic is obstacles. And I'm going to ask all three of these gentlemen the first question. So starting with Ben, what's the biggest obstacle manufacturers face when building data infrastructure for AI and predictive operations?
Hey, sorry, I dropped out a little bit there. I just put my camera off to help with bandwidth, but I'll start with question one because I caught the beginning of it. So you can hear me all right, Rick?
Yes.
Yeah. I come from a different perspective from the other two panelists here, which hopefully will be really useful for the attendees. I'm very much about building the right foundation, getting the data kind of situated in the right environment to allow your engineers, analysts to leverage it using best-in-class tools in the way they want to use it, right? Most AI projects don't go anywhere. Most initiatives maybe don't prove value enough and kind of end up in like POC purgatory. So I'm all about kind of creating the right foundation, creating a data backbone that's versatile, accessible, based on industry standard formats, simple to use, that can support the development of new use cases. So I'd say that's A for me. That's one of the biggest obstacles, is focusing on building that right foundation. And then secondly, corporate buy-in. It's really one that's often overlooked. So I think organizations that can prioritize initiatives like these as strategic from the top down tend to be more successful. Without support from these decision makers, ideas can often never gain traction. Teams operate in silos, and as I said before, pilots tend to stay exactly that. So one way we're trying to encourage a lot of our prospects to get that kind of corporate buy-in and kind of sponsorship from key decision makers is to focus on the value-based approach, which, focusing on kind of return and value that each use case can deliver. So I'd say those are the two obstacles that I see. Probably the biggest one is corporate buy-in. And then the second one is focusing on building that kind of like that right foundation, that versatile data backbone that can support any use cases you throw at it.
Thank you. Thank you so much, Ben. Sam, same question to you. What's the biggest obstacle manufacturers face when building data infrastructure for AI and predictive operations?
That is a great question. To me, it's things like the physical nature of manufacturing systems, the diversity of data networks and data representations. They pose headwinds, but even more than the technical difficulty, the heterogeneity, the physical aspects, the environmental aspects, even more than all of that, it boils down to funding and investment is the most difficult thing, per what Ben talked about. And funding and investment, in my experience, is in the form of money, either direct investment or loss tolerance during enhancements, and then time. And it hasn't been common to have a lot of either of those in manufacturing operations, money for capital expenditures and then time to enhance or optimize. Production environments are cost centers, and they also are the beating heart of a company's business engine. And once production's running, any change to those underlying systems carries really significant risk. And so any enhancement has to typically, be compared to increases in short-term production quotas. And it's a really hard gate to pass. So I think more so than other areas of industries, manufacturing and industrials have a harder time, I think, given the nature of our businesses.
Absolutely. I've heard this conversation so many times, in the IT to OT chasm where, OT saying, no, we only have one job, and that's to keep production running.
Exactly. And they are right. That is their incentive. So you're fighting pretty deep structural incentives that need to be there. And so it's what I'm excited about is that there are pressures significant enough now, whether downward macro pressures or even potential ROI that might shift and change that and have sort of established norms of production systems, maybe a little bit more tolerant of change and rework than we have in the past. So.
Absolutely. Okay. Calvin, same question for you. Biggest obstacles manufacturers face when building data infrastructure for AI and predictive operations?
I'm going to try to not repeat what these guys said because their answers are fantastic, but I'm going to add on a big piece we run into a lot is culture. There are such huge cultural differences between the OT side of the world and the IT side of the world, and then even the executive side of the world. And now with predictive maintenance, AI type solutions, you're getting the data science side of the world thrown into that mix. Everyone speaks a little bit different language. We all have different terms for different things. And sometimes just trying to talk to each other is the hardest piece to even get a project going, because everyone wants it their way. But if everyone isn't on the same page to start, it's a non-starter.
Absolutely true. We're fond of saying, people, process, data, technology in that order. And so many things get tripped up, from culture, for sure. Going back to you, Sam. Next question in this space: what are the biggest architectural mistakes manufacturers make when they first try to build a predictive maintenance or AI initiative?
Yeah. So I think there's a huge gradient to what it means to be AI ready, and every point along that gradient is valid and still considered, in my opinion, AI readiness. But at scale, there are really great established patterns for the type of data readiness that AI and analytics and data science needs. And those look like this. So you need something to reliably collect data proactively, passively, in flight, and at rest. Something to normalize the data into a consistent data type system, whatever that may be. Something to compose and construct and govern data models, often the end data products that are used for business purposes. Something to store the data short and long term. Something to provide access to and move data between systems and people of interest. And then this is really the hardest one to put together. It's what we talked about before. It's the multidisciplinary team of diverse cultural backgrounds in that business, enabled on AI and with deep familiarity of, or at least deep relationships with the teams and orgs that have and their knowledge domains, both for correct data interpretation, but also how to derive application of AI for your unique business and your unique workflows and your unique organization by providing use cases and proof points and context. So all of those, 6, 7 different things, those are really difficult. And some are ready with 1 or 2 or 3, and some are ready with none. I think the biggest mistake is maybe not seeing the elephant first and then figuring out how you're going to eat it.
Oh, for sure. I think when we look at these projects, it's no surprise that predictive maintenance is the first one they tackle because it's so easy to put boundaries around. Yeah. And I think that jump from predictive maintenance to a quote AI initiative can be really challenging. And I remember talking to someone in this space, a vendor in this space, saying that the biggest issue they faced going into clients was they expected there to be an easy button at the end of the session. That when this is all done, we'll just press the button and it'll give us all our answers.
Whether it's internal people or consultants or vendors, it's challenging when to navigate those business value conversations. It's really challenging.
Great. Ben, what's one capability at the edge that manufacturers consistently underestimate when they try to scale?
It's quite a funny answer, but I would say the one capability they underestimate is scalability. So pilots and MVPs are often strung together quickly to prove value, and there's nothing wrong with that. I love the fact that this technology is really simple to get to know and simple to test. I'd much rather have it that way than a long paper-based analysis where people can't begin to prove value and test things out. But the trouble is everything does work at low scale, and that's not realistic. Don't overlook the full scale requirements. So I'd say that's the biggest thing that people overlook, technically and commercially, right? This means consider your initial production workload and the future state workload as well. Load test it, technically prove that it meets your requirements, and validate the commercial implications of this. So, practically speaking, and I've been guilty of this as well, way back when in my early professional services days, but I chat to customers every week that have kind of a jumped up POC that's made its way into prod based on not using the right tool for the right job. Let's say relational databases for a time series workload, like MS SQL or Postgres, for example. And it's only when you start to scale that you'll hit these inefficiencies.
Honestly, and I've heard the same thing, and this is not, I won't mention the vendor, but it was one of these situations where their solution could handle traditional PLC data very quickly and without much problem and without, and then as the particular auto company started to proliferate large numbers of IoT sensors, suddenly they found the choke point. And it was like, they were, of course, blaming the vendor that was doing that, kind of collection and analytics piece of it. But in more cases, it's exactly what you were talking about, is not understanding what it takes to scale.
Yeah.
And
Yeah,
that can be a real problem.
And there's one more point I would just add really quickly, which I actually loved Sam's analogy, where he said the biggest problem is not seeing the elephant before you can work out how to bite it. And this is a problem that a lot of customers that I encounter undergo, and it's versatility. So selecting a solution, industrial connectivity, processing, and transfer, data transfer, that's versatile enough to accommodate for your entire platform requirements. Not all sites are created equal. Not even two machines of the same model are often created equal. So focus on that versatility and how you can cater for that variability. Yeah.
Oh, for certain. I'm old enough to remember, people putting in direct numerical control of machine tools. And you'd same thing. You'd find two or three of the same machine control, but one of them acts totally different.
Oh, yeah.
Find out that some engineer decided that the best way to fix it was to kind of rewire the controller himself without much documentation. And while you don't expect to see that with IoT, you can also rely on a plant having everything brand new. And certainly there is not an economic model for rip and replace. Sam, how do you maintain data quality when you're pulling from 20-year-old PLCs? We just answered this question, but
close to my heart.
Close to your heart, as far as
spent a lot of time with
data quality. 20-year-old POCs and brand new IoT sensors simultaneously in operation.
Absolutely. So not to be funny, but a group of people with all the modern software engineering expertise in the world who happen to be dedicated to writing code to help handle the nuances of physical systems, regardless of how old those physical systems are. No, but I joke. But really, you either buy or build the tools that provide careful implementation of messaging management. So a lot of error detection and a lot of error handling, junk bytes, missing data, reestablishing connections after unexpected drops, tools to speed up or slow down messaging exchange, and a lot of attention to the physical network transition points like RS-485 to Ethernet or coaxial cable to some other physical medium, and what protocols flow over that and what are the speed and size limitations. So doing all of this so reliably that your business can rely on it like they rely on their electrical utility turns out to be pretty hard work, and it's a good business to be in if you're Litmus and the work that I've done in the past. So it's difficult. There's a lot of nuance and engineering that go into it, and it takes a group of people who are dedicated to really getting out in the field and seeing the systems, integrating to them, getting them on loan or buying them, bringing them in-house, and then beating them up to the point where them, you can whisper to them better than anybody else, and then you write that down in code. So it's hard, and it's a good. It's one of the reasons why I appreciate the Litmus folks, is because it's not integrating to physical equipment, whether new or old, and increasing data reliability is. It's hard. It's really often underappreciated, but it's just the keystone of what every digital system really relies on. So,
right, and I'll sort of toss this out to any of you guys. You're seeing also sort of tribal knowledge issues. The same sort of things where, we've always done it this way, and it may not make logical sense, but we've always done it this way.
Yep, exactly. It's sometimes those practices are too quickly dismissed, especially by folks who might be coming in without the same level of background. And a lot of times the practices are structural, are band-aids for deep structural issues that we might have an opportunity to address at this point. We just have to bring in that team, that multidisciplinary team, the cross-cultural team, the folks who understand business value and money, and the folks who understand production systems and network infrastructure and IT.
Sure. Well, that's sort of it for the roadblock questions. The next set of questions here are all about readiness, and this one starts with Sam. You want to take a quick drink of water or something before we?
No, I'm good. Thank you, though.
Manufacturers want AI-ready data, but they don't know what that means. So from an architectural standpoint, what minimum standards or patterns should every plant have in place before thinking about predictive operations?
Oh, great. I think I inadvertently might have rattled off a few of these patterns earlier on when answering another question. So I hate to repeat myself, but ultimately, if the biggest problem that manufacturers face is number one, realizing that the data is your own, the expertise is your own. Take advice on how to do it, but the why and the nuance is going to be provided by people in your organization. That's full stop. No one can teach you how to apply AI to your unique org without you bringing your unique org context to the table. Hardest thing to do. The patterns are hard too, and the elephant, you have to see the elephant in order to see what patterns you need, but that honestly is easier than getting to the point where you know your company's workflows and context, and you can bring all of that to the table and apply it correctly with AI. So from a what manufacturers should consider for patterns, it goes back to, something to collect data proactively, passively, in flight, and at rest, something to normalize that into a type system, something to compose and construct and govern the data products, the data models, something to store that short, medium, long term, something to provide access to that data and deliver that data to systems and people. And then again, the hardest one is a multidisciplinary team in order to see the elephant, design how to eat it, and then make sure the systems run well for the unique nuances of that particular business operation.
Exactly. Yeah. There's something called collective intelligence, which I've been reading about lately, and that's sort of the basis of the whole thing, is that where you get the ability to do this is by building a multidisciplinary team.
Exactly.
If you bring in a bunch of people who have all the same experiences and the same background, you're going to get the same results. So
exactly, and some of that is steeped in some ideology and groupthink, and you don't want that. You want to create a system that protects against that to get the best results as fast as you can. And it might be hard, might be fighting matches, if you will, but in the end, it is worth it.
Sure, absolutely. Ben, time series data from sensors generates massive volumes. How should manufacturers architect for both real-time performance and long-term storage?
I would say by choosing proven components that support those requirements. So for example, you wouldn't choose a pure data lake or data warehouse-based solution to support a real-time use case with extreme performance sensitivity, alerting, dashboarding, that kind of stuff. And likewise, you wouldn't select a component that didn't offer cheap long-term storage and historical data access, perhaps archiving, if that was a capability your tech stack required. In my experience, every prospect I speak to thinks they have the most data ever in their use case, and it's all relative. But it's just focusing on your requirements and making sure you understand what they are, where the value is delivered, and choosing proven components that can support those.
Right. The strategy is not collect everything, sort it out later. So the follow-on here is, what criteria do you use to decide what stays at the edge, on-prem or in the cloud?
Yeah, it of course depends. I've seen both ends of the spectrum here. It depends on the customer's requirements around their edge data capability, durability, perhaps bandwidth for data transfer from the edge into the centralized IT network, the amount of normalization and processing required, that we've been talking about, legacy equipment, the age of the equipment, and cost implications of this data transfer and storage at different tiers. Are they in the cloud? Are they on-prem? Many of my cloud, to go to one end of the spectrum, many of my cloud-based customers simply normalize the data at the edge and transfer full or near full granularity into their centralized network, whether it's the cloud as a future-proof approach. So they've got kind of a single interface, a single point of access, and they kind of just have their full granularity raw data there just in case, and they can begin to work on it there. But many of my on-prem customers cannot do that. They are forced to transfer a processed or lower granularity downsample version of this to their centralized data storage, because that is, some server racks, and they have to pay through the nose for some SSD storage. So they can't, you know what I mean? It depends on what end of the spectrum you're on. Yeah.
For sure. Great. Calvin, what does it actually take to get reliable contextual data flowing from thousands of industrial devices at scale?
The simplest answer to that is strategy and discipline. If you don't have a plan in place to handle that kind of scale, you're just gonna have a bad time with it. And Ben mentioned before, the one-offs are one type of thing to handle when you're doing that. But as you start handling different sites, different lines, if you don't have a way to quickly and easily add that new edge device, add that new sensor to your system and orchestrate it easily, you're going to take a project that may take, a couple months and drag it across a couple years. So have that strategy in place before you even start the project itself.
It goes back to what Ben said earlier too, right? Make sure you understand that things are going to be diverse, and you can't just pick precise tools for each type of device. You need the precision tools, but you also need to be ready for variation and plan for that.
As much as you'd be able to do it that way, one size does not fit all, and I think that's really the key
Right.
to all of this. Okay, last question of this section, Calvin. Security and data accessibility often conflict. How are leading manufacturers solving for this for predictive operations?
So a couple just really simple things up front. Have good security policies in place as an entire organization. Keep your data plane, your control plane separate if you can. Simple end-to-end encryption is really important, but something a lot of people don't think about. One thing we're starting to see more and more, which I'm super excited about coming from a software world, is software-defined networking, because it does allow for a zero trust between devices, and you can control what types of data flows from device A to device B on which ports. So I think those are some of the major things that are happening, but getting into ABAC and RBAC is also really important. It goes out to an overall strategy much more than what is happening at the one individual place.
Yeah, do you have some examples where you've seen this done effectively?
One of our customers, they went with I'm going to call it an old school strategy, but it is effective, of basically isolating everything from each other. But so they were a cloud enabled customer, but what they did is they bridged their cloud to their corporate network and created an air gap between it. But because it was in the cloud, you could follow a lot of that software defined networking ideals. So person A, data from machine A could not get to machine B without, going through a couple more steps. And with that cloud environment, it did allow that more granularity of who got to what and for how long they were able to get to that data.
Interesting. Okay, so the next and final section here is the future. So we'll start with Ben. How do you future-proof time series infrastructure to support AI capabilities that don't exist yet?
Yeah, I absolutely love this question. And it's again, repeating myself a little bit, but I'll delve a little bit deeper. So I'd say broadly put, build the right foundation, that's versatile. We spoke a lot about that, accessible, and based on open industry standard formats, so you can supercharge your team to work very quickly, very fast development agility. Don't architect yourself into a corner, or avoid it if you can. So just digging into those points there, I'd say data quality and access. So ensure your data is standardized and usable, and importantly, easily accessible by your tools and engineers. So what this usually means is building an ingestion architecture that standardizes your data, obviously caters for the versatility of inputs that you're going to have. Again, we spoke about that. And a data storage strategy that removes plant-based data silos and hopefully consolidates. That's where I've seen a lot of success. So giving a single interface, a single point of access to hang off all of your use cases, and more importantly, a sandpit for your team to work and improve out AI use cases. So that was kind of data quality and access. And then the second one would be, here at Influx, we're quite passionate about open and industry standard formats. and adhering to them. So don't get lured in, I would say, often by proprietary closed systems, or maybe just be wary of them. They're rigid black boxes, very difficult to adapt to changing requirements, and can sometimes create a vendor lock-in situation. I know, Calvin, we very often speak about historian replacement projects, so I'll leave that one there. I work quite closely with Calvin. So things like MQTT, OPC UA, well-documented open APIs, industry formats in query language like SQL, and file formats like Parquet, because everyone knows you need to give a data scientist a Parquet file a day to keep them happy. So using solutions that have a commitment to that, because otherwise you do end up in the kind of black box vendor lock-in situation. So I would say these things together build the right foundation and will supercharge your development agility. That would be my key piece of advice for kind of future-proofing an industrial IoT data platform. Yeah.
I'd like to add one other comment to that.
Sure.
Because, again, coming from a software background, you learn really early the power of decoupling systems and making sure you do have your data plane separate from your data storage, your ingest separate from those other things, your visualization layer separate from everything else, so that if a new tool or format comes along, you can quickly swap out that piece and not disrupt the rest of your system altogether.
Yeah, exactly.
Excellent.
That's it.
That's excellent. Thank you.
Mitigate swapping out those components. So not just the integration methods, but as Calvin said, keep them separate. Yeah.
Just the whole idea of future-proofing something is it's really an interesting topic, because the number of times that organizations have thought that they had future-proofed things, only to be looking at it years later and going like, what was I thinking? And especially with the AI capabilities, I think the most common thing I've heard from both vendors and end users as they've gone down the AI journey, started down the AI journey, the most common thing I hear from all of them is, we never even thought of being able to do that. So, and I think because of that makes this whole future-proofing discussion even more fraught, because it's hard to predict where you're going with all this. So those are really good, Ben and Calvin. Those are really good sort of guidelines to go with. I appreciate that. The next question's for Calvin. What is the most overrated part of smart manufacturing that distracts from real data problems plants face every day? I love this question, so I can't wait to hear it.
I'm gonna give a very controversial answer and then try to back myself away from that controversial answer. But I'm gonna say AI in general is one of the most overrated parts of smart manufacturing right now. And what I mean by that is, so many people think that AI is going to be the silver bullet to solve the problems, when the old adage of garbage in, garbage out holds so true for any of this. If you aren't spending the time, making the data better, setting up pipelines, getting the data to central locations and working with it, AI isn't going to do anything but, make your problem worse. And I've got a really great example of this. Is we were working at a customer and we had a lot of really, really smart data scientists on it. And they were looking at the data and they said, hey, there's a problem right there. Well, yeah, the problem was the plant wasn't on at that time, but they were interpreting it wrong. So being able to understand the data is so key to making an AI succeed. So it's both the most overrated part of it, but it's also the piece that has so much potential.
Yeah, absolutely. And I mean, even the term smart manufacturing, it's it's very broad, but very thin, I think, as far as what the understanding is of it, and what really applies to things as being smart manufacturing. And I came from the MES world, which is the poster child, the grandfather, I should say, of technologies that have multiple definitions that no one can agree on. And so to see a big part of what I do as an analyst is basically get briefings from vendors. And over this past year, it's just been really fascinating to see everyone's take on AI, how far along they are with it, what they believe that it means, and what they believe it's going to be capable of. And what's nice though is even with all of that, there's still a healthy enough amount of skepticism on the vendor community side that makes me feel quite a bit better about the future of smart manufacturing. So we have gotten to the last question well ahead of time. So this question is for each one of you, and I'm going to do it in reverse order, so Calvin is not left with listening to people give his answers. So Calvin, looking 3 to 5 years ahead, how do you see data infrastructure evolving for industrial operations, and what should companies be planning for today?
I'm gonna look back to a previous question, and I really believe that the days of the monolith and the gated ecosystem are going to come to an end fairly certain, because they have to. Mm-hmm. As more organizations start to involve IT and data scientists, each one of them have their own sets of tools that they want to use, and the OT side of the fence is going to have to start adopting with it, and you can't do that if you've got a walled garden away from it. Another piece that is tangential to this, and I think is really important about looking to the future, is observability inside of our systems. As things grow and scale, being able to observe what's happening, not at the sensor level, but at the controlling level, is going to be very, very important.
Sam, you want to take this one on? Looking 3 to 5 years ahead, how do you see infrastructure evolving?
Absolutely, yeah. I used to say data is the new oil. That was popular, right? Big data in the 2000s, and when Azure and Hadoop and object-oriented storage was getting popular in enterprise IT. I would argue now data products are the new oil. Structured, contextualized, representative information from production systems, from business operations. That is the most valuable thing on the planet. Objectively, well, maybe subjectively, maybe not objectively, but to me anyway, data products are the new oil, and AI and predictive analysis are the engines that'll use that oil. And those engines in 5 years are either running in your environment and driving down costs and driving revenues up, or they're running in your competitor's environment while they grab the land that used to be yours in the market. And so whether you have that land or not will depend on whether this new type of oil is flowing. And it's important to invest now in the industrial data pipes. So establish knowledge of and tools around industrial data systems, get a group of people in your company together, give them the tools and the latitude to solve today's problems with the tech at the same time that they lay the data pipes for even bigger, broader future efforts. So that's what I see 3 to 5 years ahead. Get the tooling, get the people up to speed now, be thinking of industrial data pipelines, and then the tooling that we can use to solve day-to-day problems today are the same tools that we'll be, building these fabrics of the future on. So it all is time well spent.
Excellent. Okay, and we'll finish this off with Ben. Looking 3 to 5 years ahead, how do you see data infrastructure evolving for industrial operations, and what should companies be planning for today?
Yeah, so I guess in terms of how I see it evolving, I'm seeing a lot of AI initiatives come on the horizon. I think it's right to treat them with a healthy degree of skepticism and also always focus on value and proving them out. But it's becoming increasingly accessible, increasingly proven in some ways. Tools are becoming infused with it in weird and wonderful ways, and kind of one of the most key things that I see at the minute, and we use it internally at InfluxDB every day, is the development agility of your team massively improving, leveraging AI agents to potentially build out a white labeled UI for a monitoring solution or whatever it is. And I can see that's kind of one of the key ways in the landscape. I mean, Calvin, we were just talking about before the call, you were at AWS. I heard that almost every booth had AI covered all over it. Yeah, it was quite commonplace. So I think getting ready for that through some of the tools and techniques that we've already spoken about, and I'll just reiterate them now. So how can you plan for it? It's that corporate buy-in, support from leaders and key decision makers, making sure that you can have support so ideas can gain traction and your teams aren't operating in silos, constantly reinventing the wheel, and pilots can flourish if they deserve to. And then again, building the right foundation, so more of a technical way that you can plan there. So creating that backbone that can support the development of new use cases. Data quality and accessibility, hopefully consolidating into kind of a single pane of glass interface. And as Calvin really articulately put, focus on open industry standards and avoiding those kind of walled garden black box solutions will allow you to build the right foundation and hopefully future-proof your stack in a way that will allow you to be ready for whatever AI drums up next and throws at you. Yeah.
Great. And Sam? Same question, which is looking 3 to 5 years ahead. How do you see data infrastructure evolving?
I think I actually answered this one, Rick, before Ben. Yep. But I'm happy to repeat myself. My wife. But no, anyway, it was about getting ready now with tooling and folks enabled on it. Solve today's problems while laying the groundwork and the plumbing for tomorrow.
Excellent.
Products are the new oil.
Yes.
Yeah, products are the new oil. Yep.
Yes.
Data products. And there's lots of books and academic literature. I mean, we're just as everything, we're standing on the backs of giants. It's just the giant community has broadened a bit, right? So now we're borrowing ideas from Amazon and their own digital transformation journey back in the 2000s when they went from 400 people to 6,000 people and invented a lot of AWS's stack that they're now selling today. So there's a lot that we can learn from Amazon about data products and from companies, big tech companies who ventured into industries like Tesla, by and large a software company that is really good at hardware too, and others. So it's there are these paths that have been laid. They just don't necessarily look like the classic OT environments and OT vendor landscapes, but there's a lot of really cool convergence happening. And companies like Litmus and companies like Influx and companies like AWS, it's great to see production systems get a bit of airtime with the folks who also care about Kafka and high-speed extract, transform, load operations. So, and if folks are interested in literature and books and things, we can follow up with some recommendations too.
Excellent. So we are a little bit early, and there's 3 more questions that we had thrown in, thankfully. So I'm just going to throw 1 or 2 of these out, and whoever feels comfortable jumping in on these. We have historians and SCADA already collecting data. Why isn't that enough for predictive maintenance?
Who wants to go first? I can give a short perspective on it really quickly. I would say a key thing that one of the key differences for people move over from historians into the time series data spaces is often context. So not only getting away from that kind of walled garden extendable system, but enriching the kind of raw PLC signal data, the raw tags that you're getting from your equipment with that additional context, which, I'm very much in the data layer, and I see myself as enabling customers for the AI use cases. But I won't get too far out of my box. But that context essentially gives you more clues in which to create actionable insights. So I would say that's one of the key differences that separates these kind of 2 solutions, that additional context that you can enrich your data with.
Excellent.
Yeah, I'd say you don't always need anything but a historian. And it just depends on the features in it, right? I mean, I think unfortunately there have not been a lot of data science features added to the traditional operations tech systems. And this is where newer vendors have an advantage. We're nimble, we can do it. We've already done it for years. And so I think it's about where folks have chosen, where the software developers and commercial software developers have chosen to spend their time, and a bit about what problems the production system engineers are looking to solve. Again, it comes back to uptime. That's been the biggest incentive, not necessarily ROI on potential new revenue streams or even levels of optimization that are reached. At a certain point, you can just hit something with the sledgehammer and, production plus plus. Do you need the scalpel and medical degree? Maybe not. But the macroeconomic factors are pushing competition greater in industrials than we've seen. And there's a lot of understanding from data science and enterprise data systems folk who are not always the operations tech folk about how valuable that data is. So there's a lot of messaging going on about how companies can make use of that data. So I think we'll see SCADA vendors start to implement more data science tools and learn from some of the data platform folks, but and welcome competition, right? That's all going to be good for consumers. So I think there's a bit of latency, I think, embedded in the production commercial software space that newer vendors are coming in and occupying, and that's a really healthy and good thing. But I don't necessarily think you have to do more than look at the tool sets you have and figure out what exists and what doesn't, and then choose a great set of tools for the gaps.
Great. All right, I'm going to move on to the questions that have come from the audience. So first one here from Rashid: how do you convince stakeholders to invest in data infrastructure first when the ROI on predictive operations isn't immediate?
I think a really great answer to this one is especially if you're thinking about, you can start small. You can start small with a lot of these solutions. Start small, but think big. Don't paint yourself into a corner with your small implementation, but you could get started for not a ton of money, and you could prove that ROI pretty quickly with one line, one plant. And if that starts moving up, then you start implementing that large scale process. But at least you thought about that at the beginning. So, you don't do the one line and they're like, oh crap, how do we add 50 more lines to this?
Right.
Yeah, we encounter this quite a lot at Influx as well. It's obviously part of our process. Sometimes I think because Influx is open source first and quite a popular solution, we often come in solving technical problems, and then we have to, with the engineering team, justify the value case and justify the spend to the decision makers. It's kind of a bottom-up approach very, very often. So we're involved in designing that value case, and I mean, there's no one size fits all. Sometimes it can be a cost justification, the cost of do nothing. A lot of the time, it just depends on the specific use case. I had one particular use case that was a sailing company, and if they had corrupt data, they lost a whole day's worth of sailing data, and they were competing to quite a high level. And if you split their budget across each of the sailing days, you could easily work out how much of their investment had been lost through losing that potential, I guess, those insights. So through embedding like a highly available solution, which mitigated against those issues and that unavailability, we could build in that justification. But that's just an example. You can see how there's no one size fits all. I think it's an entire job role, value engineering. Yeah.
All right. Next question from Sheldon. Given change management is the largest hurdle, especially for large enterprises with complex solution integrations, where data may or may not be directly accessed, what would be the next big gun to polish? Interesting question.
I'm thinking, because I'm not exactly sure how to answer this question, I'm not sure if I'm interpreting it correctly. Like, what is the next big challenge?
Yeah, what's the next big, the next big project to go after? So if change management is the largest hurdle for large enterprises with complex solution integrations, where data may or may not be directly accessed, what would be the next thing to go after?
I'm going to go back to one of my first comments of cultural alignment. That kind of aligns with the change management, but making sure everyone is on that same page and you all speak the same language. because if you can't get past that step one, you're not going to get to step two.
Mm-hmm. All right, question from Julie. How can I convince my leadership that we need to take the time to see the whole elephant before biting into it? Everyone seems to be in a hurry to fail fast.
I'll take a swing at it, which is contradictory to a lot of my thought process of I really firmly believe in the fail fast mantra. Again, coming from software, that's the way that world works. But I always like to preface that with it's fail fast with like within a vision. So I don't think it's a problem to fail fast if you have something that you're aiming towards. Mm-hmm. So try something. If that fails, try the next thing. I don't know if that answers that correctly, but it's
I'd like to add to that as well, Calvin, because you gave me a thread to pull on a little bit. I think I agree with you that it's not necessarily exclusively a bad thing. I think again, getting your data infrastructure into a position where you can fail fast is not a bad thing. You can build the right foundation so that you can try out these things for quite a low level investment in terms of effort or potentially, commercial investment. So I always encourage customers, never trust what you see on the website, always prove it out and go through that process of figuring out your requirements. But that being said, there is always an exercise of understanding exactly what your requirements are and attempting to see the elephant. But yeah, somewhere in the middle, I would say definitely go through that kind of consultative approach with your team to extract what are the must-haves, what are the nice-to-haves. But don't be afraid to get going, because I think some of the customers that we deal with end up in a kind of a little bit of a loop of kind of paper-based analysis, and things eventually die out, where it's like, if you could go ahead and build the right foundation to prove the value, then things can gain traction and can prosper beyond that.
Another follow-up for you, Ben, is like, stuff is moving so rapidly at this point. The technology is evolving so quickly that if you want to try to get ahead of some of this stuff, you're going to have to take a few risks on some technology that may not be in fashion 6 months from now, a year from now. So you've got to find the balance between, trying to get ahead of the pack or being a little bit of a laggard.
Yeah. And some of the POCs and pilots won't work, but that's part of the process. Yeah.
Yeah, this next one is from Saeed. I'm a software engineer recently focusing on IoT, from collecting data at the edge, normalizing it, pushing it into analytics dashboards. What key practices or architectural principles would you recommend to engineers who want to build reliable end-to-end IoT data pipelines?
I like this question. Mostly my advice is don't give up on the best practices you have been taught as a software engineer. Understanding CI/CD pipelines, data management is really crucial, and it will usually give you a little bit of a step up on a lot of organizations that aren't thinking about those things. Again, getting to scale, understanding those philosophies, they're so crucial. So use what you've learned as a software engineer and apply it to this industry. It'll be incredibly valuable for you.
Absolutely. Just to add to that as well, don't neglect the future requirements. I think in the first answer, and we've all touched on it quite a lot today, it was building a single thread sometimes won't be versatile to apply to a different set of sensors or a different piece of equipment or potentially a different site. So try and incorporate some of that variability, as a template that you can apply and scale. So really focus on that point of scalability. And then when it comes, one thing that I see time and time again, this is just a really small point that just jumped into my head, is that a lot of our customers come and speak to us as they've kind of built out that pilot, and they don't design a data model in a particularly usable way. So I'd say a really key point is try and build out a data model in a way that supports your query pipelines, that supports query simplicity. If you end up having one table per sensor and then you want to put all the sensors onto one chart, it's going to be very computationally expensive and put a lot of load onto your system. So consider the end users, consider how this should be accessed and what the use cases are. And that hopefully can inform a lot about your data model and how this stuff should be kind of normalized and collected. But yeah, I would say scalability if you're starting out.
I can't believe we did this entire discussion without mentioning data modeling once,
Yeah.
given how crucial it is in all of this.
Yeah.
Data products.
Yeah.
No, but it's a good thing to think about. It's a hard nut to crack, both to get buy-in from others and to rally folks around even a plan or a set of shared goals. And I like to think if you break it down to any type of advancement you need, you have to connect to things, you have to collect to things, you have to normalize, and then you have to construct models. And then you need to distribute those and store them. So if you can get your group of folks to agree on at least those things, then they can fail fast and move quick, and they'll just be in one of those buckets each time. And then you can split hairs about what tool or product is best to occupy each bucket or more than one bucket. So, but just try to rally folks around a general guiding set of concepts. And then don't worry too much about fan favorite products, one versus the other. Do your due diligence and test them. Apply them, learn about them. And I love the idea of bringing some more software development expertise, and don't be afraid of that. Don't be afraid to go read a book or listen to an audiobook like me or read podcasts, because the industrial data pipes, the data fabrics that we're building right now, whether to support them after they're there or build them out, they follow classic software design principles. So they are not necessarily, vernacular for us OT engineers, as much as we love OPC-DA and UA and object-oriented interfaces. It's still, some of the software development concepts are a little farther away from operations tech than they are, say, for enterprise IT. So it's been great to speak with everybody today.
All right. Hey, thank you, guys. I want to thank Sam, Calvin, and Ben for their amazing insights and knowledge. Thank the sponsors once again, Influx Data. Your support ensures that we have all of this great content to share. Thanks to our attendees for listening in and for your great questions. And now it's time to move on to the next session, which is preparing your data layer for AI-driven product and supply chain decisions. And that is sponsored by AdLib Software. Have a great day. Thank you all for attending.
Thanks, everyone. Pleasure.
Thanks, everyone.